all right, I think I might have said what the symbol is already. It's actually called infinity. Some people will call it plus infinity. Same thing. They both basically mean the same thing. So we have infinity, this figure 8-like symbol. Again, it's not a number. I've seen people treat it like a number. And maybe I did that when I was an undergrad. I don't remember. But don't do that. Okay, that's good. What about, okay, also we have the other side, so to say. We have this minus here. And again, this is just notation to keep on going to the left forever and ever. This means you keep on going to the left forever and ever. That's all we're saying here. Okay? That's all this is saying. You keep on going to the left forever and ever. In the negative direction, that is. Again, you could think of it as the end of the number line in the minus direction, in the negative direction, on the left side. This is actually read as minus infinity. Excuse me, negative infinity. Some people read it as or call it minus infinity. Same thing. But again, it means you keep on going to the left in a negative direction forever and ever and ever. All right, good, good. Now, we also have, so with this special notation, we can actually accomplish our goal. Namely, what do we have here? Well, if we wanted to include everything to the right of the number a, so before we took a to be 4, but if we want to include everything bigger than a, we're going to use this infinity symbol. Namely, we're going to have an open circle above a, right? Because we're not including a, so we need an open circle there. And we have the arrow pointing all the way to the right, towards the end, to the right, that is. I mean, that's graphically, that's how we would sketch the graph of this infinity, of this interval. This interval, though, is the answer to our question. Mostly, actually, this new notation is. This interval is all numbers strictly bigger than a. And this is how you graph it. Okay, so this interval, again, is all numbers bigger than a. See? Also, I wanted to put this in. We never put a square bracket next to infinity. Next to a you can, but not next to infinity. Now, why is that? Well, because infinity is not a number. It's just fancy notation. Okay, what's this interval? Well, this is the same idea, but in the other direction. This is all numbers smaller than a, to the left of a. And what do we do? Well, we have an open, how do we graph this? We have an open circle above a on the number line. We also draw an arrow pointing to the left. We draw an arrow pointing to the left, as you can see. The arrow indicates we keep on going. Good. All right. Okay, so that's good. And again, you know, what we have was the graph. It's all numbers smaller than a. All numbers smaller than a. Good. Okay. Good. All right. So we have that. We also can have square brackets. Again, we never put a square bracket next to minus infinity. You know, we just don't do that. We never do that. Because again, minus infinity is not a number. You only put open brackets next to it, as here. Excuse me, as here. Okay, well, as you saw in that slide, we can have these intervals, these square brackets we can put around the number a. we can include a number, a finite number. And the graphs would be the same as this, except these open circles would be filled in. They would become closed circles. Okay, they would be closed circles. And what's nice about this new notation is we can represent the collection of all real numbers as an interval. And that's what this is. All numbers here, okay, all numbers here are all real numbers, that is, are in this interval. So this is the collection of all real numbers. Okay, now, are there any questions on this? Okay. All right, so that's the interval stuff that I wanted to go through. Now let's actually get into the inequalities that we're going to solve. An inequality, I know it says linear inequality above in the title. I mean, that's mostly what we're going to deal with. Inequalities in general, this is what one obtains when from an equation, when the equal sign is replaced by one of these four symbols. Okay. Again, when you have to get an inequality to make one, you take an equation and you remove the equal sign somehow, erase it or whatever, and you replace it with one of these four symbols. Then by definition, you have an inequality. By definition. So we have that symbol. We have an inequality. And just like equations can have solutions, okay, just like equations can have solutions, inequalities can as well. Inequalities can also have solutions. Namely, the solutions to an inequality in the variable x, it's all the numbers you can plug into the variable that make the inequality true. An inequality, just like an equation, can be true or false. That can happen. It can be true or it can be false. An inequality. And again, all the numbers you could plug into the variable that make it true, those are the solutions. And again, they will be intervals. We also have compound inequalities. That's when you have two inequalities, one on each side, so to say. You can have these. And these have solution sets which are half open intervals or half closed intervals or open and closed intervals. You'll see what I mean actually on the next slide. But these are compound inequalities. These actually come up. This is when, again, you have two inequalities at the same time. All right. So what are the solution sets? Well, these are the solution sets for these inequalities. If you have something like this, x less than b. So here, the solutions, these are all numbers less than b. Less than b, right? Well, what solution set is that? This interval. This interval is actually all the numbers smaller than b by definition. What about here? Same idea, except we include b now. And that's what this is. That's what this is over here.